Bismillahirrahmanirrahim. My dear student, Assalamu alaikum. This is your Iqbal sir. I hope you are safe and sound. This is my fourth video on static electricity. This video is for class 9 and based on chapter 10 static electricity. Our learning objectives from today's presentation: number 1, electric force. Number 1, electric force. Number 2, Coulomb's law. Number 2, Coulomb's law. Number 3, mathematical formula of Coulomb's law. Number 3, mathematical formula of Coulomb's law. Number 4, similarity between Coulomb's and Newton's law. Similarity between Coulomb's and Newton's law. Number 5, how we can solve math by using Coulomb's law. How we can solve math by using Coulomb's law. Let's start. Electric force. Unlike gravitational fields with only one type of mass to act upon. In gravitational fields, one type of mass to act upon, but in electric fields have two types of charge that they can make an electric force on positive and negative charge, and these two type of charge is attractive and repulsive. Attractive and repulsive. Here the similar or like charge repel each other. Like charge or similar charge repel each other. On the other hand, the unlike or dissimilar charges attract each other. Here in these two objects they have similar charges, so they repel each other and the force between these two objects is small. In these two objects no force is acting because here the first object has both positive and negative charge. It also has a positive and negative charge, so they are acting both attractive and repulsive force, and these two forces cancel each other. That's why there is no force acting between these two objects. The law of conservation of charge. Charge can neither be created nor destroyed. Charge can neither be created nor destroyed. Coulomb's law. The force between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of their distance apart. Here the force between 2 point charges is directly proportional to the product of their charges. If these two charges is Q1 and Q2, then the force is directly proportional to product of Q1 and Q2, that is F proportional to Q1 Q2, F proportional to Q1 Q2, and inversely proportional to the square of their distance apart, and inversely proportional to the square of their distance apart. If the distance between these two charges is r, then F proportional to 1 by r square. Now combining these two equations, we can get F equal to K into Q1 Q2 by r square. Here K is the constant of proportionality and it has a value of 9 into 10 to the power minus 9 Newton meter square per Coulomb square. Newton meter square per Coulomb square. There is a similarity between Newton's law and Coulomb's law. We know that Newton's law, the force between 2 point masses is directly proportional to the product of the masses and inversely proportional to the square of their distance apart. That is, the force between two masses is directly proportional to the product of the masses. If two masses are m1 and m2, then F proportional to m1 and m2, and inversely proportional to the distance apart. If distance is r, then F proportional to 1 by r square. Combining these two equations, we get F equal to G into m1 m2 by r square, where G is the gravitational constant and which value is 6.6742 into 10 to the power minus 11 m cube per kg per second square. Coulomb's law. The electrostatic force between two charges Q1 and Q2 separated by the distance r has the magnitude F equal to K Q1 Q2 by r square. The electrostatic force between two charges Q1 and Q2. Q1 and Q2 is the two charges which is separated by the distance r. And its magnitude is F equal to K Q1 Q2 by r square, where K equal to 1 by 4 pi epsilon naught, and which actual value is K, which actual value of K equal to 8.99 into 10 to the power 9 Newton meter square per coulomb square. This is the actual value, and this is the approximate value of K. This is the approximate value of K, and this is the actual value, where K is the electromagnetic constant. K is the electromagnetic constant, and epsilon naught is the permittivity constant, and which value is 8.85 into 10 to the power minus 12 coulomb square per Newton meter square. Here Q1 and Q2 charge which is separated by distance r, and as these two charges has same charge, they repel each other. That is, the electrostatic force is repulsive force between these two charges. If these two charges are negative, both are negative, as they are both are similar charges, they also repel each other. But if these two charges are opposite charge or dissimilar, they will attract each other. Force is a vector quantity, we know that, and so it has a magnitude and direction. It has a magnitude as well as direction. The direction of electric force is always along the line connecting the two charges. The direction of the electric force is always along the line connecting the two charges. Here an example is given your textbook. Question: a plus 1 coulomb charge and a minus 1 coulomb charge are placed at a distance of 10 centimeter. How much force is acting between them? We have to find out the force acting between them. The two charges will attract each other. Why? Because they are opposite charges. One is positive, another is negative. The force acting between them, we know that according to Coulomb's law, F equal to K into Q1 Q2 by r square. Here given Q1 equal to plus 1 coulomb and Q2 equal to minus 1 coulomb, and the distance apart is 10 centimeter. Distance of 10 centimeter. So here r is the distance, and which equal to 10 centimeter. Now if we convert the centimeter into meter, we have to divide it by 100 and we will get 0.10 meter, because we know that 1 meter equal to 100 centimeter. So in order to convert centimeter into meter, we have to divide it by 100 here. Now dividing by 100, we get 0.10 meter. The constant of proportionality K equal to 9 into 10 to the power 9 Newton meter square per coulomb square. Now putting this value in above equation, we will get F equal to 9 into 10 to the power 9 into 1 into minus 1 divided by 0.10 square Newton, and we will get minus 9 into 10 to the power 11 Newton. Here force is negative, and the negative force indicates the attractive force, because these two charges are opposite charges, opposite or dissimilar. If they are positive charges, if they are similar charges, the force will be positive. And which will indicate the repulsive force. But here we get F is a negative, which indicate the attractive force, because these two charges are dissimilar or unlike charges. One is positive, another is negative.